For our final speaker today, I'm pleased to introduce Duncan Watts, whose work on cultural markets, which we'll hear about right now, I think actually laid the groundwork for some of the work we've seen in terms of thinking about positive reinforcement processes and so on. And I think this is truly one of the more innovative bits of research on social dynamics that I've seen in the last for a long period, because it actually went out and created in essence artificial worlds to test these ideas around around reinforcement and the like. And so Duncan, of course, has done many things. I think we all know about them, and they've been a terrific addition to the fields of network science and the science of success. So in any case, I'll leave it there, and Duncan.
Thank you, David. Thank you, Laszlo and Darshan, for having me here today. It's been a pretty packed day, and I'm sort of struck by the almost archival nature of my talk right now. It's only this work was published in 2006, which doesn't seem that long ago, but I think everything else that we've heard today has been published since then. So it's sort of an indicator of how kind of either of extreme selection bias on the part of the organizers or the recency of this emerging field. So what I want to talk about today is or start off talking about today is this puzzle that I should say that this work is joint with was done back when I was at Columbia University, and it was done jointly with Matt Selganic, who is now just got promoted to full professor of sociology at Princeton, and I'm proud to say that at Microsoft that we have managed to sort of snaffle him away from Princeton, so he'll be starting at Microsoft Research New York next month. And also Peter Dodds, who is now a professor of statistics at the University of Vermont. So sort of way back in 2004, when Matt arrived at Columbia as a graduate student, we were sort of talking about possible problems to work on, and we were sort of very engaged by this kind of stylized empirical paradox that you encounter when you look at markets, cultural markets, by which I mean markets for books, music, movies, art, and so on. And the first thing that you notice when you look at these markets is what we call extreme inequality of success. So if you think about the hits in these markets, like Michael Jackson's Thriller and the music world, or the Harry Potter series, or the movie Avatar, these are not just more successful than an average candidate in these markets. They're many orders of magnitude more successful. And so you might think, well, that's true, but it can be easily explained that all of these objects that I'm talking about here are clearly better, much better than average. They're uniquely good. They're produced by uniquely talented people, and so these huge differences in outcomes are driven by very large differences in quality. But if that were the case, then you would expect that these differences would be obvious ex ante, and in fact, when we go back through history, we see, at least sort of anecdotally, quite the opposite, that many of these ex post sort of hits were rejected and scorned many times. I'm sure that we can all sympathize with that. When our papers get rejected, we know that they're great works of science, and somehow the editors just don't get it. The same thing happened to J.K. Rowling, and those editors are all very sorry for themselves right now. And so we have this kind of paradox that, on the one hand, we look back, we see this extreme inequality of success, but when we look forward, we have great difficulty in making accurate predictions, and even these motivated experts who have lots and lots of skin in the game, lots of experience in their industries, are somehow unable to make these predictions reliably. So what's going on? Well, I want to propose two explanations. This little figure over here will make more sense in a moment. The first is what I want to call the common sense explanation. It's not really common sense, but it's sort of the intuitive explanation that you would come up with if you're thinking about this, which is first is that people sort of know what they like. They might not be able to explain it in easy to understand terms, but when, it's sort of the Justice Potter version of pornography, he knows it when he sees it. The same thing is, you might think the same thing is true in cultural markets, that you know excellence when you see it. And so we can rank things uniquely from best to worst. So this is the sort of x-axis here. We're ranking everything in the world from best to worst. But then we have this other factor that comes into play, which is technology. And modern technology now allows us to almost costlessly reproduce new copies of a song or a book or a movie once it has been made. And so because we have this near costless reproduction, then it's no more difficult for any consumer to consume the best product than it is to consume the second best product. And so everybody chooses to consume the best product. And the result is what we call a convex demand function. So that's what this is, that if you look, the relationship between rank and market share or demand is highly nonlinear, and the best object in the world might only be a little bit better than the second best object, but can get a lot more demand for precisely this reproduction reason. And so this is actually sort of the core of a famous paper by Sherwin Rosen in 1981, who made essentially this argument, that really the explanation of this paradox between unpredictability and inequality is that the inequality has been driven at the top end by very small differences in quality, and that just sort of noisiness of estimation strategies can account for the errors that experts make. Okay, the other explanation that I want to put forward is what I call the social influence alternative, which starts from a very different premise, that people actually don't know what they like, that they have sort of unclear preferences, they're not exogenously given, they're highly malleable, and there are many good reasons for why this might be true, that there's way too many things out there, it's impossible for any one person to actually go and form sort of consistent informed preferences about all the various options in the world. And in any case, we might very well be influenced by what other people are doing. And there's actually two quite different mechanisms at work here. One is what we call social learning. So this is what Coco was talking about this morning, that I may not place any actual utility on what you think in terms of my own utility, but I understand that you know something that I don't know, and so I pay attention to what you're doing. And the second kind of explanation is the conformity explanation, where I actually want to like the same things that you like. So there's a lot of, you might, in the cultural world, one way to think about culture is a set of shared objects that allow us to interact with each other, right? So that we both are able to talk about Shakespeare, and that it doesn't really matter whether it's Shakespeare or something else. The point is that we are sharing some sort of common reference point. And so you can have, these are two quite different sort of underlying psychological explanations for why we care about what others are doing. But from the point of view of this argument, it doesn't really matter. Either one of them generates the same outcome, which is that things that are popular tend to get more popular. All right? So this is the mechanism of what we call cumulative advantage. And as a number of speakers have emphasized today, there's a lot of work on cumulative advantage processes. They've been called many things over the years. Robert Merton coined the famous phrase, the Matthew effect, meaning that the rich get richer and the poor get poorer. This is from the book of Matthew in the Bible. Preferential attachment is Laszlo and Reika's contribution in the late 1990s with respect to network growth. Increasing returns economics, Brian Arthur in the early 1990s. So there's a lot of different names for these processes which refer to, sort of at a high level the same sort of thing. And we know that in all of these, when we have these kinds of random cumulative advantage processes, we get highly unequal distributions of outcomes. So that's the inequality of success. And we can also obtain various phenomena that are reminiscent of unpredictability, such as lock-in in markets with increasing returns. So this is the famous cases of VHS versus Beta and QWERTY versus Dvorak keyboards, where even sort of where indistinguishable or possibly even inferior alternatives can eventually win out in the end. Okay, so we have these two different arguments. The common sense argument claims that inequality arises out of a collective agreement on quality, which can then be ranked, and the unpredictability arises out of small measurement errors. The social influence argument implies that inequality and unpredictability are actually built into the aggregation process itself. So even if you knew everything about individual preferences, you still wouldn't be able to predict the outcome. That this ranking is itself, the ranking from 1 to n is itself an endogenous outcome of the process. So now the unpredictability becomes inherent to the process itself. So this is sort of like rolling a die. You know, you can sort of know everything about the die, and you can know everything about physics, and you can know everything about the tabletop, and you're still not going to be able to predict which particular face is going to turn up. So how would we test between these two alternatives? Well, if the common sense argument is correct, then we ought to be able to, there's essentially a deterministic mapping from quality to success. And so if we were able to rerun history many times, then the same things ought to win over and over again. And this, the amount of inequality that we observe should be independent of how much people know about what other people are doing, right? If we're really just sort of relying on our own intrinsic preferences, then the mapping should be deterministic, and it should be invariant with respect to social information. If the social influence argument is correct, then what we ought to see is the opposite, which is that the rank orderings will change from one realization of history to the other, and the inequality and the unpredictability both ought to be functions of social influence. So the more people know, or the more people influence each other, the more people know about what other people like, the more inequality and unpredictability we ought to be able to see. So this is an interesting idea. The problem is that in order to test it, we have to be able to rerun history many times, and that's not really possible to do with history, which only gets run once. And so instead, we'd like to be able to create an artificial environment, sort of like the playoff series that we're currently enduring in basketball, where we recognize that we have these two very talented teams, and the outcome of any particular game might be a random event, and so we want to try to extract the bias in the coin there, and so we have to run many independent trials, and that's what we do in sports, but we can't do that in history, unfortunately. And the other thing we can't do in history is actually vary anything, right? We can't, we just have one sort of observation. We can't actually sort of get in there and tune the knobs of social influence. Okay, so what we would like to be able to do is sort of run history in a lab, so to speak, and be able to rerun it many times independently, and also be able to control what we think of as social influence by controlling who was exposed to what. But of course, this design then poses another problem, which is that in order to do that, we have to sort of create multiple versions of history. So if we're thinking about a cultural market, we have to have lots of different objects for people to make choices between, and we have to have lots and lots of different people making those choices. So just to generate one single run of history, we may need hundreds of participants. And then in order to get multiple runs of history, we need thousands of participants. And then in order to have different experimental treatments, in each one of which we have multiple runs of history, we need to have tens of thousands of participants. And this is more undergraduates than we have at Columbia. So the solution, which seems totally obvious now, but was not so obvious back in sort of 2004 when we were starting this, was to actually create a virtual lab online. And so this is what Matt did. He built this thing called Music Lab, which you arrive at this website. You click on the home page. We ask you some questions about yourself, and then eventually you end up at this sort of key page here, where you're shown 48 songs by bands that you have never heard of. And each one of these grid squares contains the name of a band and the song. And then up in this top right corner here, you can see a little number, and this number indicates that it's the number of downloads that song has experienced before you arrive. So there's a little bit of information there about what other people like. So if you click on one of these grid squares, the song itself starts streaming through your web browser, and so you can sit there and listen to it for as long as you want, and then you can give it a rating from 1 to 5 stars, which have the usual meaning. And then once you have rated the song, you have an opportunity to download it. And this is the action that we actually pay attention to, although the rating is highly correlated, so it doesn't really matter which one you look at. Okay, so what you don't know is that when you arrive at that website, you're randomly allocated into one of two conditions. The first one, I should rather say the second one, is the one that I just showed you. This is what we call the social influence condition. So this is where you see this weak social signal about how many times the song has been downloaded by people before you. In the other condition, the independent condition, it looks exactly the same except there are no numbers. Okay, so all you do is you have a grid square, you have 48 songs arranged in the grid, and you just sort of click on whatever you feel like clicking on, and you literally have to do everything independently. The other thing that you don't know is that if you happened into the social influence condition, we further randomly assigned you into one of 8 different worlds, as we call them, and each one of these worlds, you only get to see the downloads of people who were ahead of you in that particular world. So in this way, we created effectively 9 independent copies of the universe, and then we just feed people in randomly into each one of these, and they all start out identically with 0 downloads for every song, and we just see what happens. In fact, we tried 4 different variations of this setup. The first one is the one that I just described to you. It's what we call the weak influence condition. We then ratcheted up the strength of the social signal in a way that I'll describe in a moment to create the strong condition. We then did a third experiment where we used a totally different population of people to test whether this was just a population effect. And then finally, we used deception, and I'll explain that in a few minutes. So what's going on here? So this is experiment 1. These were mostly teenagers recruited from a website that was somewhat popular at the time, but is now defunct. It was called Bolt.com. It was an early social networking site for teenagers, and they were kind enough to put banner ads for our Music Lab experiment up on their homepage, and people would click through from Bolt and come to our server and participate in this experiment. And so we can see here what we're measuring is whether or not people even pay attention to this little social signal that we have, these numbers that we have on the grid squares. And so you can see on the left-hand side we have the social influence condition, on the right-hand side we have the independent condition. And here I've ranked every song from 1 to 48 in terms of its market share. Market share is defined as the number of downloads that song has received at that point in time, divided by the total number of downloads at that point in time. So at any point in time, I can rank all these songs from 1 to 48, and then I can ask, what's the probability that someone's going to click on that song as a function of its rank? So you can see in the social influence condition that there's a very, very strong effect here at the top end. It's really a top 10 effect, that these songs are more likely to get clicked on than songs in the pack or down at the bottom. And you can also check that in the independence condition, there is no such effect. These 2 little outliers are most likely songs that have somewhat catchy names. I think there was a band called Stunt Monkey that was sort of a better name than most of the other names. And so there was a slight name effect here, but the name effect is not correlated with the ranking. Okay, so this is a real effect, but it's at the individual level, and so that's good for us to know. It's a good sanity check. But really what we care about is the collective level. In particular, we care about inequality and unpredictability. So how are we going to measure that? Well, in inequality, there's a very, very standard measure called the Gini coefficient. It's basically just the expected difference in market share between 2 randomly chosen songs, normalized between 0 and 1. So all you really need to know is that when G equals 0, all objects have exactly the same market share, so this is a completely equal world. and when G equals 1, one object or one song gets all the downloads and nobody else gets anything. Okay, so it's the most unequal world you could possibly have. At the same time, we measure unpredictability. This is sort of a measure that we made up. There are other ones that you could come up with as well. So this is really the expected difference in market share across worlds. So this only applies when you compare across worlds. And so it's really sort of just think of it as, if you knew the rank ordering, or if you knew the market share, the vector of market shares in one world, how much would you be able to predict about that same vector in another world? And so when that equals 1, you have a completely deterministic, when that equals 0, you have a completely deterministic universe where the same rank ordering gets spit out every time. And when that equals 1, you basically just have a random reshuffling of songs from one world to the next. Okay, so what do we find? The first result is that consistent with our social influence hypothesis, inequality and unpredictability both increase in the presence of social influence. So over on the left-hand side, we have our 8 different social influence worlds, and here we have our 1 independent world. And on the right-hand side, we have social influence and independent conditions. So you only get one measure of unpredictability because it's an across-world comparison. And so you can see in that all cases, the Gini coefficient is greater in the social influence worlds than in the independent condition, and the unpredictability measure is also greater. You might say, okay, well that's true. Directionally that is consistent with a hypothesis, but these are not very big differences, and some of them are sort of right at the margins of significance. Is this really sort of a big deal? It's a good question, and so that led us directly to experiment 2, which is to ask, okay, this was a very, very weak social signal. It wasn't even clear to us ex ante that people would pay attention to it at all. So now let's make it a little more salient, and the way we're going to do that is presenting exactly the same information. Everything about the design is exactly the same as what I just described, except now instead of randomly scattering these 48 songs in a grid, we're going to helpfully rank order them for you from most popular to least popular. So this clearly makes it easier to see what the rank ordering is. And indeed, we find that the individual level effect is exactly what we had hoped for. So you can see the open circles correspond to experiment 1 in the social influence condition, and the closed circles correspond to experiment 2. So you can see a couple of things are different here. First, at the top end, there's a much larger effect for experiment 2. And interestingly, and Coco mentioned this as well, there is a little bit of a tail effect here. So basically people are scrolling down to the bottom of the list to see what the worst song is to try to bracket the quality range. And this is a little bit of an artifact of our experimental design, which only allowed for us to have 48 songs, which is actually not very many. If you had 48,000 songs, it probably wouldn't be worth scrolling all the way down to the end. So what do we find? Well, now we have 2 comparisons to make. So first we have the within experiment comparison, where we look at social influence to independent condition again, and we have exactly the same result, where in all cases the social influence worlds lead to greater inequality and unpredictability. You can see that the difference is much bigger, and indeed if we look across worlds, you can see that the Gini coefficient has gone up consistently in all the social influence worlds, as has the unpredictability. And just to sort of put some context on these Gini coefficients, the average Gini coefficient in experiment 1 is about 1/3, and the average Gini coefficient in experiment 2 is about 1/2. So this is Sweden, and this is Uganda. Okay, if you think about economic inequality, right? So you might think 0.33, 0.5, are those numbers different? Well, go to Sweden and Uganda and decide if they're different. They're pretty different in economics, so they're different here. Okay, so the third result, what about quality? Where is quality in all of this? I'm sort of emphasizing that everything except intrinsic quality, and the thing is that the quality does not go away. That if we take these two experiments and we average the performance over all 8 worlds. Okay, so what are we doing here? We're trying. The x-axis is our best measure of what we call quality. We really, I think in the paper we refer to it as appeal. And what this is popularity in the independent condition. You know, sociologists and other scholars argue endlessly about how one should define quality. Here we have a metric that is at least internally valid, which is that, you know, appeal or quality is what people like when they don't have any information about what other people like, right? So this is sort of completely confined to the experiment, but it is an independent measure, right? So we rank everything in terms of this metric, and we call that quality. And then we say, well, how successful are you in the social influence conditions? And you can see that on average, success is positively correlated or is increasing with quality, right? So on average, quality matters, but there's still a lot of scatter. And the scatter is, you know, so each of these columns here is 8 dots, which correspond to the 8 realizations of a particular song. And so you can see that exactly the same song is experiencing very different outcomes from world to world, even though nothing has changed. The other point that I would like to note is that when you go from the weak influence to the strong influence condition, you see basically the same story, but everything is just amplified. And you see extreme variation at the end here. Finally, just going back to Schumann-Rosen's argument about convexity, he sort of argues that convexity is really a function of technology. That this is like a thing that, you know, the technology, the reproduction technology, is totally exogenous to the market itself, right? It's just something that allows the best thing to get reproduced endlessly at low cost, and so convexity shouldn't have anything to do with social influence. Here we find, and you can see this line here is the cubic. These are cubic spline best fits, and you can see there is in fact convexity here, but the convexity here is much greater. So now the convexity itself is actually a function of the aggregation process. This is not a function of technology. This is a social process of people responding to what other people like. Another way to look at it. This relationship between, or this trade-off between quality and randomness is to just do a scatter plot. So here we have the rank market share in the independent world, and now we have the rank market share in the social influence worlds. And you can see a big cloud of dots with some gaps at the top left and bottom right. And what those gaps tell you is that the very best songs never do terribly, and the very worst songs never do extremely well, but everything else is possible, okay? So if you look in the middle, you know, so the very best songs have quite a bit of variance associated with them. The very worst songs also have quite a bit, and the ones in the middle can really land up anywhere. And so there is one song, what is the song called? I forget the name now, but one song came in number 1, I think it's this one here. Came in number 1 in one world and, you know, number 43 in another world. So that song like almost like got the extremes. I really should have that slide. Okay, so what have I said up till now? Individuals are in fact influenced by their observations of what other people are doing, and the stronger the social signal, the more they're influenced. Collective decisions are also influenced. When people know what other people like, popular songs become more popular and unpopular songs become less popular. Inequality increases, but at the same time, which particular songs become the most popular becomes increasingly difficult to predict. And so this is where the paradox is that when you give people this social information, it's useful, right? People like this information. We like to have bestseller lists. We like to have expert opinions. We like to have reviews, whether expert or from the crowd. And so they are actually telling us something. This is helpful information. So individuals are getting more information than they would in an independent world, and yet precisely because they're getting that information, they feel less, or they're less motivated, or less, they're not forced to contribute their own independent or private information, and so the market as a whole is aggregating less information. So this is a phenomenon that is known as an information cascade in economics. Okay, so a couple more questions. You might think, okay, fine, teenagers, whatever, teenagers are, they're very sort of susceptible to social influence, but once they become adults, then they, they have taste, they have sophistication. Surely adults won't behave this way. We can check that. And if you're a marketer, you immediately start thinking, how can I manipulate this? In fact, this is Arno's question earlier. Can we sort of, do experiments where we artificially change the appearance of rankings and try to game the system in a real life version of what Arno was describing? It was several years ago. The author, David Weiss, bought 15,000 copies of his own book on Amazon and then returned them all a couple of weeks later. Of course, by that stage, it had gone on the New York Times bestseller list and actually continued to stay on the New York Times bestseller list. Okay, so I'm just going to dispatch with the population one very quickly. This is really just a replication of the second experiment, the one that I just described. But here we recruited the participants instead of from Bolt.com. We actually sent messages to about 60,000, not all 60,000, but some subset of the 60,000 people who had participated in a previous experiment. This was a replication of Stanley Milgram's Small World experiment. So these were mostly older college-educated professionals. And now we had one independent world and only two social influence worlds because we were trying to conserve our subjects for our final experiment, as I'll describe. So we found that there was a different average rank ordering. So these, as you might expect, the older professional people had somewhat different tastes on average than the teenagers. And so you do see a population effect there. But the effect of social influence, looking the comparison between independent and social influence conditions was exactly the same. We still saw almost identical effect sizes for inequality and unpredictability. So the way to think about this is that if you have some distribution of success in your market, the population is sort of moving the objects around, but the distribution is staying the same, okay? So the distribution is really what we care about here. Okay, if you're trying to predict, of course, then you actually do care about the population as well. If you're trying to predict like which song is actually going to succeed, then you would need to take into account the population preferences. Okay, so finally, experiment 4 is the sneaky one. This is the one that all the marketers want to do, which is, and so the way we did it was we were running experiment 3, and at some point we stopped running experiment 3, or the subjects couldn't tell the difference. We picked one of our two social influence world. We threw away the second one. We made 2 copies of the one that we had picked, and then we flipped these copies, right? So Arno was describing a very a minor perturbation where you're just like awarding a barn star or you're just sort of giving a few dollars. So this is sort of a small perturbation. This is a huge perturbation. This is, where the most popular song gets made to seem like it's the least popular song, and the least popular song gets made to seem as if it's the most popular song, and we flipped every pair in the middle, right? So everything got inverted with its mirror opposite. We kept all the numbers the same, and then we just let everything run. And so, one question that we were asking is, can we see what Merton called a self-fulfilling prophecy, which is a false definition of the world that through the actions of people responding to that false definition becomes true, right? If people think a song is popular, does it actually become popular? And we see some evidence here that this might be the case, and we see some evidence that it might not be the case. So this is a tricky figure to look at. So here we have 2 songs. This is the most popular, so this is experiment 3, as I described earlier, and here's the most popular song, and here's the least popular song. Now at this moment, we flip these 2 things around. In one world, we keep going, in the other 2 worlds, we flip them around. So the solid lines describe the world in which everything just kept going along as before, and you can see that song 1 continues on its merry way, and song 48 continues down in the doldrums. In the inverted world, song 1 gets a one-time boost. Sorry, song 48 gets a one-time boost, and song 1 gets deep sixed to 48, and then we let them see what happens. And you can see that, so there's two interesting things here. So first, these dashed lines are steeper than this solid line. So in addition to its boost, song 48 starts to grow faster than it did in its unmanipulated world, right? Likewise, song 1 is growing slower than in its unmanipulated world. So both these songs, so the song that we're boosting is getting a continuing benefit, the song that we're penalizing is getting a continuing cost, but because there are these large differences in intrinsic quality, song 1 is still catching up to song 48. And so you can construct a thought experiment where this is where we ran out of subjects, basically. Right? We sort of exhausted everybody, especially ourselves. This was sort of months of running this thing. But we thought, okay, well, what would happen if we had an infinite supply of people? Could we just let these things run? Just extrapolate, do a linear extrapolation over the last sort of 100 people, and say, you could sort of imagine that these two lines are going to cross at some point. So at some point, song 1 is going to reclaim its rightful place as the best song, and we can go through this thought experiment for every pair of songs, and we can ask, given its rank in the setup, in infinite time after this perturbation, where would it have ended up? So this is the unchanged world, and as you can see in the unchanged world, like everything is very much clustered around the diagonal, that the setup basically always predicts the final rank. In the inverted worlds, you see it's a complete mess, right? You see that the number one song was actually going to, it looked like it was on track to reclaim its number one ranking, but the number 2 song wasn't, right? So there's some songs are along the diagonal here, which means they're going to recover their place, but you see there's a lot of songs that are off the diagonal, which means that songs that were unfairly, so these are the songs that were unfairly promoted, these were the songs that were unfairly penalized, and a lot of them are being affected. At the aggregate version, you see something analogous, which is now we look at the correlation coefficient between these worlds. This is at the moment of inversion. Suddenly these inverted worlds become completely anti-correlated with the one that, obviously we just flipped them, so correlation coefficient's -1. And now you can sort of see them scrambling back, right? So the people are doing, people are injecting information here. They're sort of, they don't know what they're doing, but they're sort of recognizing that the songs at the top are not as good as they were expecting them to be, and the songs at the bottom are maybe a little better than they were expecting them to be. And so they're doing some sort of reinversion, but they're also getting stuck, okay? At the same time, we can see the Gini coefficient is going down, right? So there's sort of an overall compression of the marketplace. So you're clearly having an effect here, but it's sort of a very kind of incomplete effect. Okay, so the final result here is that, at the end of the day, the songs, well, this is really just sort of a different version of what I showed you earlier, that if I look at the projected rank in the unchanged world, so this is sort of where things ought to have ended up, and this is where they actually ended up, and I can see a negative slope here. So some of these songs are able to recover, but there's a negative slope in both these inverted worlds, so we are able to generate self-fulfilling prophecies at the level of individual songs. So songs are experiencing, so this manipulation is in fact having a real effect on the long-run performance of songs, but at the aggregate level, we were not able to sort of achieve what we had, I guess, in our evil dreams had hoped was possible, which is actually sort of create lock-in to the sort of to the mirror image universe. So this is sort of the summary is you can fool some of the people, all of the time and all of the people some of the time, but you can't fool all of the people all of the time. The market is actually doing some sort of figuring out. And the other thing that was interesting, and this is not even a result that we sort of had a hypothesis about to begin with, this was something completely unexpected, is that this gross manipulation actually makes the whole market less popular. So if you look at just gross total downloads in the manipulated worlds, they were much less than in the unmanipulated world. So what's happening is people are kind of coming in and they're looking at what they think is the best song and they don't think it's very good, but they assume everything else is worse, and so they just leave, right? And so there's a lesson here for Arno's marketers that yes, you can, this manipulation might, if you're just manipulating one thing, you might be able to get it to pay back. But if everybody starts doing that, and then the market becomes so distorted by these, or the information in the market becomes so distorted by everybody attempting to take advantage of this strategy, then in fact consumers just say, we don't like this market. So too much distortion is bad. What are the implications of this? Well, we're studying music here, but I should have said at the very beginning, this was Matt's idea to study music. I wanted to study modern art because I feel like nobody really knows what they like in the modern art world, but they pretend that they do, right? But Matt was very persuasive that there was an intrinsic kind of payoff to, we didn't have any money to run this experiment, so we had to do something that people would do for free, and he was right that the kids these days, they like to download free music, and so there was an intrinsic payoff to participating in this experiment. So we ended up studying music, but really what we care about is collective behavior in the presence of social influence, and so you can all think of many examples of other kinds of processes where this sort of phenomena might show up. And it's relatively intuitive at the individual level. I don't think any of us really have a problem admitting that we're influenced by the opinions of our friends or coworkers or even a little bit the media. But the really unintuitive or counterintuitive claim is that when you allow for this sort of micro-level process of influence, you really have this intrinsic unpredictability at the collective level. And it's not something that you can get rid of just by obtaining more information. I mean, it's amazing how much we love the idea of being able to predict things. And many talks today have been about prediction. Many efforts in the real world are aimed at prediction. And every time prediction does poorly, there's always someone else who comes along and says, yeah, but if we only measure this thing, then that will enable us to make better predictions. And what this is saying is, no, there is a limit, right? That here you can know everything. You can put these songs through Fourier analysis. You can put people in brain scanners and make them listen to songs. You can make them fill out surveys. You can do participant observation. You can know every single atom in their bodies, and you still will not be able to predict which song is going to become a hit because it's intrinsic to the process itself, okay? So this, I think, is a very deep and not at all popular insight, right? And I know it's not popular because people tell me that they don't like it. And they think it's depressing and they think it makes the world devoid of meaning. I don't believe that, but I do believe that it changes our interpretation of success. So when we look at successful people, we make some sort of inference about why they're successful, and usually the inference is that they are better than others, right? And maybe they're better in some sort of traditional notion of quality. Maybe they're just better at appealing to the masses, right? That they're what the market wanted. They were able to, even if you think that Donald Trump is a obnoxious, bombastic idiot, you probably think he's exactly the right kind of obnoxious, bombastic idiot because look how rich he is, right? He must have done something right. Well, what this suggests is that maybe not, right? That on average, quality matters, right? What we're calling quality matters. But the average is a funny kind of average because it's an average over many runs of the universe, and you never ever see that, right? You only ever get one life, and you only ever get one realization, and in any given realization, there can be a huge amount of variance. And so this is very consistent with Merton's classic theory of the Matthew effect, which was originally applied to scientific careers. And Daniel Rigby has written a very nice book called The Matthew Effect, which was published in 2010, where he shows similar effects across all sorts of different industries and occupations. But it's very hard to convince yourself, when you see two people who may have started off being very similar and 20 years later they have very, very different outcomes, it's very difficult to attribute these outcomes, these differences in outcomes to random chance. And here we encounter another a famous effect called the halo effect, which is where you impute to the individual attributes of quality that are actually based on your observation of success, so that you see someone as successful and then you look at what they did and you decide that what they did must have been smart because they're successful, right? So the common sense notion of cause and effect is good processes lead to good outcomes, bad processes lead to bad outcomes. But in fact, what we do very frequently is that processes are interpreted as good or bad depending on what we know about the outcome. So the combination of the Matthew effect and the halo effect, it's a real doozy. Like, it really is very, very hard to know what to do when you can't evaluate quality based on outcome. And I should just close by saying I don't think that people that I should lose my job or anything. Laszlo should lose his center. I think that there are good sort of sociological reasons to reward success, because you want to give lots of people an incentive to try. But it does suggest that winner-take-all markets are far less meritocratic than they seem. So I'm going to finish now with a sort of sales pitch for a field that doesn't yet exist but might one day, of experimental macro-sociology, of which this is perhaps an example, where we're using the web to run experiments on a scale that is sort of historically impractical. They're still very difficult to run, by the way. I mean, this has been, we sort of thought there'd be hundreds of experiments of this type by now, and there really haven't been, and I think it's actually still really difficult to do this. We hope that it'll become easier. This is something we would love to do at Microsoft, and I hope to come back in years to come and talk about new experiments. Thank you.
Should we just take a question or two
And then I have to go get in my cab. Yes, Sheen.
I enjoyed this paper greatly when it was published, and it informed my research. That's the reason that in my experiments I use a financial market, because you mentioned financial market casually, but financial markets are categorically different from cultural markets, because in a financial market you can take advantage of my stupidity. So if I wrongly pick a mediocre song as number one, you can produce a lot of mediocre songs, sell them to me, depress the price of mediocre songs, and make money in the process. So why do you think that this would happen in the financial market? Aren't financial markets immune to this kind of herding and cascading?
Well, they may be. I think though that there's a lot of evidence of people herding in financial markets, right? In fact, this is your day traders, and this is why they lose money, is because they're buying high and selling low. So any kind of trend following strategy is going to suffer from some of these effects. And I would say that at an even more macro level than sort of price fluctuations in financial markets, if we think about something like the last financial crisis, right, you absolutely see something like this, where money is really an abstract thing these days. It's an abstract concept, which is like I have a medium of exchange, and it works as a medium of exchange precisely to the extent that we both agree that it is a medium of exchange. And the minute that we disagree about what this thing is worth, then you see huge fluctuations in the value of money, right? And we've seen this for hundreds of years in the U.S. banking system, then there was this sort of long moderation period from after the passage of the creation of the federal deposit insurance. And then we see really one of the explanations of what happened in the last financial crisis was actually a bank run on the shadow banking system. That you have all this private money that's been created, and everybody was treating it as if it was worth 100 cents on the dollar, and then all of a sudden everybody thinks, no, it's worth 20 cents on the dollar, right? So, you know, what I can sell this thing for really depends on what people believe, and what people believe depends on what they think other people believe. So, you know, the sort of mystery of the last financial crisis is how a sort of, you know, roughly $100 billion shock to the subprime mortgage sector turned into like a 10 or $20 trillion shock to the financial system. And a lot of it is through this, like, people just losing faith in things that they previously believed had value. So I really think that this, you know, at a sort of very macro level, these processes of social information and social influence do lead to massive volatility, even in the financial world. But I'm also very cautious about, you know, about sort of analogizing across substantively different domains. And I think that you know, if you really wanted to make it stick, you would have to go do it in the right domain.
I think we better.
Okay.